Next questions from Nuki-kun. How do spatial variables work internally? Is it just greater than or less than type stuff in C#, or is there further level that I'm realizing? Yeah, it's a lot more advanced than that. We are using a spatial acceleration structure from Beppu physics. It's called bounding box tree or bounding volume tree. Sometimes you like you can see like what's the word, abbreviation BVT, like bounding volume tree. And what it essentially is, you sort of like recursively subdivide a space. So say you have like a bunch of things. You have something here, 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 maybe you have something over here. So what the system will do, it'll, you have like your root. This is your entire space, and it's gonna progressively split it into like, into like smaller kind of bits. So there's gonna be like, for example, this one, and then this one's gonna get split, say it splits it like, this way and this way. And then this one gets split like, here, and then this one gets, for example, split here. And then this one gets split like, like this, and then like this. So sort of like, a tree structure. And then like when you're searching, you start from the root and you're like, and for example, you want to figure out, is something here at this point? And what it can do is like, it's going to be like, okay, so this point is not contained here, so I can ignore this whole part. And there can be like, a lot of other stuff here. So this one has like, further subdivisions as well, just a whole bunch of stuff. Here, but like, it essentially looks, is it either here in this half, or is it in this half? And it's like, okay, it's not in this half, so I can just eliminate this whole completely, stop considering this half at all. And that is, and it's gonna be, is it in this half, or is it in this half? It's not in this half, so I eliminate this half. And like, then it just looks in this part. And usually, if the tree is well balanced, that tends to like be very, very fast. Like the complexity is like, it's some like a logarithm of some number. I forget like what exactly. But like it tends to scale like, if you are doing a loop, if you do a loop, say like you have a million things in a system and you want to do like, a search, at worst you will have to search a million items, which is, you have to do a million steps to find the thing you want, which is gonna be slow. With this kind of system, because it's sort of like, halving it. So like if you like if you assume like optimal tree, it's optimally subdivided, you're essentially splitting by half. So you start, first step is you have million objects, you split it in half, you have, now we have like 500,000, split it in half, you have 250,000, you split it in half again, you get this much. And like the numbers are like going down very, very quick. You could probably calculate like how much that is, like with the logarithm. I think it's gonna end up like being something like 6 steps. I think half of this is like something like 6. I don't actually know what exactly it is, but so like yeah, so this is gonna be about like 13 or 14 steps to find the item you want. So like you keep like having it, and like it goes very fast. So instead of having to do, let's say like this, 30,000, 15,000, and it just kind of keeps. And once you do like the 13 or 14 steps, you find the item you want. So instead of having to do a million steps, at worst you have to do like 14 steps with a million, with the same amount of items. So like, these algorithms tend to be very fast.
Eliminate like huge swaths of the area at once is like the important bit.
Yes. Yeah, it's like you essentially like every step of the way, like you're sort of halving the number of items you have to search. And it doesn't always like end up like being like the tree can be suboptimal, but it's still gonna be like, way less steps than a million. So yeah, it's and plus like Beppu physics, like it like Norby has like you just really optimize it like really well, so like it tends to work pretty fast.